And let's rewind a little bit and figure out where that 1.451 came from. It would have been when the velocity is 0. So I had to take a derivative. On one this simple, you could take a derivative by hand, but you could also do the derivative thing. Math 8. Take the derivative with respect to x of y1. I don't want to retype that whole thing. Vars, y vars, function, y1, when x equals x, because I don't want it at one spot, I wanted it at all the spots. And just to make this clear, I'm going to turn off the first graph, because I don't want to see the position, I just want to see the velocity. And it usually takes a little bit longer to graph velocity, because it has to take a derivative at all the spots on the screen. So considering all the derivatives that thing is taking, that's a pretty quick graph that it just did. I'm going to change my window a little bit here. See if that's enough. No, it's enough to see where it crosses the axis. Alright, so we're backtracking. I'm trying to find that 1.451. Second calc 0. Left bound, right bound, guess. Okay, there's that 1.451. But I want to know all of that. I want to remember all of that, and I'd really rather not write all of it down. So here's the trick. Either write all of it down because you're going to need it later, or if you quit out of there and you just press X, it remembers that as the most recent X. Now, as soon as you start doing something else, X takes on different values. So I want to store that. So I'm going to press stow. And I'm going to store that as, you can pick any letter you want. I'm just going to store it as A.
Now whenever you type A.
Now I can use that anytime I like. I can use A as that 1.451.
Until you overwrite it.
Until you save something else as A. Yeah. So now back on this distance from 0 to 1.451, we can do y of A minus y of 0 and see what that is. Oh, I guess I should call that S, especially since I haven't labeled what y is. So vars, y vars, function. So evaluate y at A minus, same thing, vars, y vars, y of 0. I mean, I already know y of 0, but just to make it look neat, let the calculator do all the work. So as long as you tell the grader, or me, what you're doing, we know the calculator can do that. So you just write that, press enter, and it's negative. It's negative because it was moving to the left. So what do I do with that negative if I want total distance?
Turn it positive.
Yeah, just ignore it or turn it positive. And since I need to be accurate to 3 decimals, I better write down more than 3 decimals. And here's what will get people. What I've written is not technically true, because position at A minus position of 0 was negative. So I'm going to put absolute value on there to tell them what I did. I turned it positive, but that's what you're supposed to do. And then S of 2 minus S of A. And again, you can use A, because once you defined what A is, you're okay to use that. Now, rather than hitting all those buttons again, I'm going to scroll up, grab that, and then go just change to and A. That one should be positive because it was moving to the right. 0.63113.
then you just add them.
And then I can just add them together. Whoops. Ooh, I almost made a mistake going in the calculator. I don't want to add them. I don't want to add those two numbers together because that one's still negative. So answer plus 8.63113. As long as I carry more than 3 decimals, then when I cut it off at 3, I'll be okay. 9.262. So the main new thing, the only new thing today is that store button. If you hit a value that you think you're going to use again, store it. And label it on your paper, that way you can use it the rest of the time. A lot of students don't do this, they just keep writing 1.451 all the way down. And the trouble is, it's not entirely accurate, and you might miss it if you don't carry all those decimals. In fact, if you want to indicate that you're carrying the decimals, but you don't want to write all the decimals, you can put 1.451 ... and that tells the grader that I know there's more, I just don't want to write them all right now. So you can do that. Again, it's just easier to store it as something and be done with it. All right, speed of the particle at time 1. So speed, I know the velocity. That's ds dt at t equals 1. How is speed related to velocity, though? If I find the velocity, how will that help me find the speed? Go in table. So y2 is the derivative. So the velocity is -3. So I don't need to type in all the derivative stuff because I did that once and now I can just use the table. But that's not the speed, that's the velocity. Speed is the absolute value of velocity. So you just take the negative off. Speed equals 3. It didn't ask for units anywhere, so I guess I'm okay without units, but that would be meters per second. All right, do you have any questions? Finish number 1. Let's see, 2 and 3 are similar. Let's just do number 2. Position of a particle is given by this equation from 0 to 3. Find the acceleration each time the velocity is 0. So go to y equals. Oh, you know what? I almost erased everything, but I think I want y2 to be the same.
Yeah.
Because y2 just says take the derivative of y1. So I'm going to clear out y1. And put in my new y1. And my window only needs to go 0 to 3, so 0 to 5 is fine. Let's see, and it's asking when the velocity is 0. So I don't even really want to look at y1. I have to put it in so that I can take a derivative of it. But what I want to look at is its derivative. So I need to tell the grader what I'm doing here. Velocity is ds dt.
Could you just write s prime? Is that something?
S prime would work. V equals 0 when. Let's see, there's one spot. Is there going to be another spot? No, that's nice. So on 0 to 3, velocity is 0 only once. Second calc, 0. Get there. Left bound, right bound, enter. And t equals 0.450. But I think I'm going to need to use that again. So I'm going to save that, store that as A. Whoops, not as answer. Although I think it would work. Let me pull it up to make sure it's there. And then I'll store it as A. And I'm going to label it A. So now I can just use A whenever I want that time. Because it didn't really ask me for the time. It said find the acceleration when the velocity is 0. So I need A. Oh, this is a weird time to pick now. I need acceleration at time A. I need A at A. So that would be dv dt when t is equal to A. So how can I find the acceleration?
You can go back into y equals, and for y3 you can do the derivative thing, but with y2.
Yeah, I can do the same thing, but now I want the derivative of y2. Math 8 d dx of y2 when x equals x. And I'm going to turn off the acceleration picture, or the velocity picture, because I don't really want to see it.
Now it's going to take just a wee bit longer.
Now it's probably going to take longer.
Because it's taking a derivative everywhere.
So crawling along. If you don't like it crawling along, you could exit out of there and just type in y2 at A and have it calculated that way. So you can do it on the graph, which I'll do since it's almost done now. Okay, that's my graph of acceleration. I want a value, and I want the value when x is equal to A. So I don't have to type in 0.450, whatever the rest of those decimals were, because I told the calculator, I need you to remember what A is, because I'm going to use it. And so there's my answer. .435 meters per second squared, but it didn't say units. So I'm going to put it just to remind you, but if it didn't ask for it, you won't have to give it. Now, that one was easy enough where that could have been a no calculator question, right? Like you could have taken that derivative pretty easily, but we want to practice using the calculator so that we get the weird stuff. Well, even question 3 isn't terrible because it's a chain rule problem.
Yeah, it's just
In fact, some of you, sine of t squared times 2t plus 1, some of you might prefer on question 3 to do it by hand. If you're tired of typing all the stuff in the calculator, and if it's an easy derivative, it might be easier.
Would the first one be v at t?
Well, be careful. It gave me v, so the first derivative would be acceleration. Find velocity each time the acceleration is 0. Well, you'd still have to plug this into the calculator, find where it's 0, and then plug that back into v. I don't think that was too bad. Mm-hmm.
My calculator just says error.
Okay.
Every time I enter something, it's a white. It's just
Okay.
error.
let's pick one for you guys to work on, and then we'll do it together. How about number 4? So start number 4. Try it as far as you can get, and in a few minutes I'll come up and do number 4. So I put in y1 to be velocity. y2 would be the derivative of y1. So the derivative of y1 at time 2 will tell me the acceleration at 2, which is negative 0.132. Or 133. Although 132 would be okay as well, because you can truncate or round.
So where's the comma?
Above the 7. Yeah. Alright, so I'm good with A. Part B, is the speed of the particle increasing or decreasing? What am I looking for speed increasing, speed decreasing? Yeah, be careful. It's not just acceleration positive. Speed increasing means V and A have the same sign. Speed decreasing means V and A have opposite signs. So we already have A of 2. That's negative 0.133. We found that already. V of 2. V is y1. So I could go to the table. I could go to the graph. I could do it right here, y1 of 2, like that. Like your calculator understands function notation, so you can use that. Y of 2 is negative 0.436. So what's my conclusion? If acceleration is negative and velocity is negative, speed is increasing, V and A same sign. Right, part C, find the time t greater than 0 at which the particle reaches its highest point. Its highest point would be, let's see, that would be where V prime changes from positive to negative. Yeah, where the velocity changes from positive to negative. So velocity was my y1. Make sure I'm looking at velocity here. Don't really want to see the other stuff. So let's look at velocity.
How do you get it to just be y1?
How do you only show? So scroll over to the equal sign and press enter, and that turns on and off those graphs.
Oh,
So you can, if you turn them all on, then it's hard to tell what you're looking at. It's get confusing.
So I can go to y2, turn it off, y3, turn it off.
Right, which is yeah. That way it's still there if you need it, but you can turn it off. That way it doesn't graph them all and take forever to graph.
Who wants to be in my B-reel?
Not right now.
I do.
Not right now.
Just 2 seconds.
I do. Good job.
I just took it. There you go.
Let's see. So where V changes positive to negative, that looks like it's happening in there somewhere. I'm going to change my window and just go 0 to 2. Change my Y window a lot as well, so I can more easily see where V changes from positive to negative. But more importantly, do you understand why I'm looking for where V... Wait, I said V prime. Do I want V prime or V?
Both.
For if changes... T reaches its highest... This thing reaches its highest point.
You want...
I don't think I want V prime. I want V to change positive to negative.
Yeah, I was confused.
Because I want my velocity to change. I was about to give the right answer with the wrong reason. I made mine 0 to 2 and negative 1 to 1 to zoom in there and see what was going on. And then I can just look in for the 0. Left bound, right bound, guess. And that is my reasoning. V changes positive to negative at t equals 0.443. And it stays negative after that, so that means it's going up until 0.443 and it's going down after that, so that's got to be the highest point. I think a lot of these you'd probably want to combine calculator with no calculator. Like look at number 9. Particle moves along a straight line, 0 to pi. Its position is given by this. What is the velocity when its acceleration is 0? So I need to find its acceleration. You can do the thing on the calculator, but it might be easier to just do it by hand. The derivative of cosine is negative sine. So my first derivative is just 4 sine t minus t. I think it's quicker to do it by hand if you know the derivatives. The acceleration is derivative of sine is cosine. 4 cosine t minus 1. So now I'll use the calculator to figure out where that happens. Cosine t minus 1. Although I wonder if my window is now not a good window. Oh, there we go. It worked out all right. So that equals 0. At t equals second calc 0. .318. Yeah, but I know I'm peeking ahead. I'm going to need to use that because I want the velocity at 1.318 ... So let me save that before I lose it. So store that as A, and then I'll call it A, and now I can just use A in my problem the rest of the way. So I want V A I've already said what V is. I can just type it in. 4 sine of A minus A. There's my answer. 2.555. So, by hand or with calculator or some combination thereof, your job, your assignment is to finish this worksheet. And then we'll start reviewing next week.